guys, it's Chris from Highland Guitars, and you're watching another episode of From the Luthier's Workbench. In this episode, I am going to take the 3D guitar body that I created in the last two episodes, and I'm going to import that into a program called MeshCAM so that I can set up the tool paths and then write the G-code that I'll need to carve that body on my CNC machine. Now, before I jump into this and get started, I should explain that the approach that I'm going to show you is what I would call a basic entry-level approach to setting up the tool paths and writing the G-code. And later on in the video, I'm going to try to explain how you can manipulate some of the MeshCAM settings in order to create G-code that is faster and more efficient. However, what you'll see in this video is perfectly acceptable for carving a guitar body on a CNC machine. So without further ado, let's jump in and get started. Before I can start to set up my tool paths in MeshCAM, I need to look at the 3D model and decide on a cutting strategy for this guitar body. And as you can see, obviously it's multi-sided, so I'll be doing carving operations likely in both the back of the guitar as well as the front. Now, in the last episode, as I was creating this 3D model, you'll notice that I included holes for the string throughs as well as holes for mounting the guitar bridge. And in truth, I really don't want to carve these with my CNC machine. I can do them faster later on with a drill press and more accurately. So I'm going to delete those in order to write the tool paths without them interfering. I'm also going to get rid of the holes for the controls where they enter the control cavity because I only want to carve those from the front side and not both the front and the back. So what I'm going to do is I'm going to zoom in on those string through holes, and I'm going to use a tool which will patch over the surface of those holes, and it's under Solid Edit Tools, and it's Delete Hole, and then all I have to do is click on that hole. So I'll do this to the string through holes and the screw holes in both the front as well as the back, and I'm also going to delete the holes on the inside of the control cavity. Now I can export the file as an STL, which is the format that my MeshCAM program recognizes. And STL stands for stereolithograph. And the options for tolerance I have set at 0.0001 millimeters, which is very small. That's going to make for a larger file. But I'll choose binary because it's the smaller file size. And I'll get a warning here about creating rapid prototypes, which doesn't apply to what I'm doing. So I'm going to hit export anyway. And that's going to write the STL file to my hard drive. Now I can jump into MeshCAM and I will import that STL file. So I'll navigate out to the hard drive where I saved the STL, and you can see it right here. That's what it looks like. Click open and I'll get a dialog telling me the overall dimensions of that STL file. Now, here I have the option of selecting 3-axis, 2-sided machining, or 4-axis. Well, logic would dictate since this is a 2-sided guitar, I would be using 2-sided machining. However, the problem with 2-sided machining is the tool path that I create has to be used on both sides the same, and I don't want to do that. I want to tailor my tool paths for each side and for different carving operations. So I'm going to go ahead and use the 3-axis option. And this is what the file looks like when it's imported into MeshCAM, the STL file. And that white line that surrounds it is the overall dimensions of just the body blankets, or just the body itself. Now the first thing I want to do is flip it over because I'm going to set up my toolpaths on the back side first. So I'm going to click rotate geometry and I'll pick the side that I want to machine, which is the back side or the bottom. And that flips the whole body over and now we can see the back of it. And what I need to do now is set up or define my stock, which, if you'll remember from the last episode, this will be cut out of a blank that's 14 by 18 inches, 1 3/4 inches thick. And then these other numbers for X and Y and Z position, I'll just leave where they are because by default, it's going to place the body right in the center of the blank. So I'll click OK, and then you can see how that white line moves out to represent the dimensions of the blank that I'm going to cut this out of. Now, if you look at the tool palette in the upper left of the screen, you'll see I have a number of options under Toolpath. For example, I can select support dimensions, which I'm not going to explain right now. I'll talk about that a little bit later. Retract height refers to how high the router will raise the bit above the work as it moves from one area to another between carves. And we want it to go at least 1/4 inch above so that it doesn't damage the wood. And then the program 0 allows me to decide where I'm going to home the router for the start of my carve. And I'm going to do it at the top surface in the very center of the stock that I'm going to be cutting this out of. And as you can see here, it places an indication where that home position will be. Next, I can set the maximum depth that I'm going to carve to. And in this case, I want the depth to equal the deepest part of these contour carves, but I don't want to go beyond that. Now, I know from measuring my blank or measuring the model earlier, 0.935 is the depth that I want to cut to. And if I turn it to the side, you can see this red line that goes all the way around. And that indicates how deep the tip of the router or the tip of the router bit will be plunged into the work as it carves these shapes. And if I look at it right on its side, you can see that that red line is right at the very bottom of that contour carve. And I don't want to go beyond that because it just takes extra time to carve and that's unnecessary. That will be taken care of later on. So as you can see on the front, that red line is well below the comfort carve that's positioned at the front of the body. So now what I can do is I can start to indicate where I want to carve, and this allows me to set up a region that will tell the program this is where the router needs to carve. So I'm going to select a polygon selection tool, and I'm just going to draw around the shapes that I'll be cutting out here. And for this first carving operation, it's only going to be the comfort contours that I have carved into the back of this guitar body. So I'll set the first one up and then I'll grab the tool again, the polygon tool, and then draw around the second comfort contour that's at the front where the neck is joined to the body. And this way, as I'm carving, it's only going to be carving within that area and not the entire surface of the guitar, so it saves a great deal of time. Now what I can do is start to set up my Toolpath parameters. And I have a tolerance set at 0.001 inches, and that's about as small as I want to go. The smaller that number, the more refined the toolpath is. And going smaller than 0.001, it just increases the amount of time. I'm only going to machine the geometry itself. I'm not going to machine the entire blank surface. Now, as far as machining margin, I'll explain a little bit more about that later. But I'll start with a roughing pass. And this is what hogs out most of the wood. And so what I need to do is select a bit. And I have a whole bunch of bits here set up in my the parameters box here. And I will select an end mill that's 1/4 inch in diameter. It's a 2-flute end mill. And then on the right side of this dialog, you can see all the different parameters that have been input for that. And I'll just go with that one. So I'll hit cancel because it's already going to be selected. And then I will manually start to input the feed rates for this cutting operation. And I will start with a depth of per pass of 0.1 inches, and that's how deep the router will cut with each pass. The step over will also be 0.1 inches, and that's how far laterally the router moves with each pass. Feed rate will be 100 inches per minute. Plunge rate is 20 inches per minute. And then I'm going to leave some stock, about 0.01 inches, and that's so when I do the finishing carve, there's some wood to carve away. And then I'm going to use a 3D roughing strategy. I'm not going to use the parallel path because that, for this particular cutting operation, it isn't necessary and it would just add to the amount of time it takes. And then I'm just going to use a conventional mill direction. Then, of course, I'm going to select the finishing pass. And what I can do with that is I can tell it to carve either back and forth along the x-axis or the y-axis, or I could even cut back and forth on both axes. And I find that cutting back and forth on the x and y axis just takes too much time. I'm going to have to do some sanding later on anyway, so I'll just select cut along the y axis. And then I'm going to select the exact same tool that I used in the roughing carve. That way I won't have to make a bit change. I can just keep it the same bit in the router. And it's going to ask me if I want to import those parameters, which I don't want to do because I want to set them up manually. And I'm going to have a step over of 0.02 inches, a feed rate of 150 inches. And you'll notice that that's 50 inches more than the roughing pass, but that's okay because we're not removing much stock, so I can move the router faster. Plunge rate stays the same. And then you'll notice here there's surface angle, and by checking that box, I can limit the angle of the surface that it's going to carve. I don't need to worry about that, so I'm not going to check it. Now, don't machine the top. This is an important feature for this because if I don't have that box checked and I write my toolpath, if you look closely, you'll notice these green lines indicate the movement of the router. It goes all the way up to that region that I defined with the polygon tool. I don't want that because it's going to leave a hard edge beyond my comfort carve and in the back surface. So what I would rather do is check the don't machine top of stock, and you'll see here as I calculate that tool setup, once the path has been established, you can see it just follows the contour of the carve, and that will save a lot of time and result in a better quality finish. And as I said before, what I end up with here are all these green lines, and the green lines indicate where the router moves back and forth as it's carving those areas. And then the red lines that you see going back and forth are the rapid moves as the router moves from one area to the other. And you can see here I can take a look at both the rough operation by unchecking parallel finish, and you can see how that router is going to move for the rough carve. And then with the parallel finish selected, you can see how the router moves to do the finishing cut. And if I zoom in, you can see all those vertical lines which indicate the movement of the router. Now I can select estimate machining time, and it tells me it's going to take about 21 minutes to carve this shape. So I'm fine with that. And what I can do now is click Save Toolpath. And what this does is it calls up a window to select a post processor. This is what's going to write the G-code. And as you can see, looking through this list, there's all these different commercially made CNC machines that I can choose from. Well, my CNC machine is not a commercially made machine. It's a machine that I designed and built myself. So what I'm going to use as a post processor is it's a generic G-code post processor, and I can scroll through this list and you'll see it here. It's basic G-code-inch, and it'll append the file with .nc. So I'll click OK, and I will navigate out to the folder on my hard drive where I want to save all my G-code files. And I'll title this Guitar Body Back Contours. And when I hit save, it's going to write the G-code file into that folder. Now, before I continue on, I want to save this project setup. So I'll click Save Job, and I will title this Guitar Body Back Contours. And this is going to save it as a MeshCAM file. So it'll be a .mcf file on my hard drive. And then that way, if I need to make any changes, I can just go back in and make those changes without having to reset up all these regions and such. Now, the next cutting operation on the back is going to involve cutting out the control cavity. So what I need to do now is I'm going to go back into my select region, and I'm going to clear the ones that I had created before, and then I'm just going to do a rectangular selection around where that cavity is. It's kind of hard to see in top view, but as I navigate around in perspective, I can see that that rectangle has encompassed the entire control cavity. Now, for this cutting operation, I need to set a deeper maximum depth than the 0.935. In fact, I'm just going to set it all the way to the bottom. Even though it's not going to cut that deep, I want to make sure that the router will go deep enough to cut the full depth of that control cavity. And then for the Toolpath parameters, what I'm going to do in this case is I'm going to disable finishing pass, because I don't need to make a finishing pass inside the cavity. And then I'm going to set the stock to leave to 0, since I'm not going to be doing that finishing cut. And then everything else is going to stay pretty much the same. I'll click OK, and I'll get the dialog asking if I want a machining margin. And since I'm not cutting a perimeter shape, I don't need the machining margin. And then here you can see the path has been set up for carving that control cavity. So then and if I hit the estimate time it takes, it's about 22 minutes. So now I'm going to save it as that basic G-code-inch post processor, again, into the folder on my hard drive. And I'm going to call this Guitar Body Back Control Cavity. And then that writes the G-code file. And then before proceeding on, I'm going to save this as a MeshCAM file in case I want to go back in and make any adjustments to my toolpaths. Now I'm going to flip the body over so I can perform the Toolpath setup for the front. And I need to delete that rectangle. And then I'll go up under Geometry and rotate the geometry again by selecting that back. And as you can see, it flips it over. However, we do lose our stock definition. So I'm going to go back in and reset that up as 14 inches wide and 18 inches tall. And then everything else stays the same. I'll click OK, and you can see it redefines the stock to encompass the entire body. And it also retains the position of the home, so I'll just leave that. Now here's where I'm going to add supports. And I'm going to create supports that are 1/4 inch tall, 3/8 of an inch wide, and they'll be placed at the bottom of the geometry. And I have to be conscientious about where I place these, because remember, the back of the body has areas that have been carved out. And if I place a support where the back of the body has been carved out, you'll notice that it's not going to work because that wood has been removed. So I have to position the supports in order to be in an area where the wood is completely solid all the way through. So I'll place my supports where I know they will actually be in contact with the sides of the guitar at the bottom. Now the purpose of these supports is to keep the body from flying around once the router has cut all the way through from the front to the back. without the supports, the body would likely bounce around and could get seriously damaged. And you can also damage the CNC machine. So it's really more of a safety feature than anything else. Now with those supports in position, the next thing I'm going to do is check my maximum cutting depth, which is 1.75 inches, and that's what I want. I don't need to establish any carving regions because I'm going to be carving the entire top of the guitar. So I'm going to go into my Toolpath Parameters, and I'm going to leave most of these settings pretty much the same. I am going to add 0.01 inches stock to leave since I will be doing a finishing pass. And I'm going to cut along the x-axis, and I'll leave all these parameters the same. Now, as far as don't machine the top of the stock, I want to actually machine the top of the stock here on the front because it's a carved top. I don't need to use any of these other settings, so I'm just going to leave those alone. Now, when I click OK, I'll get a dialog which asks me if I want a machining margin. And what the machining margin does is it will add margin around the perimeter cut. And so I'll hit yes, and that's going to automatically calculate the amount of machining margin based on the diameter of the bit. And that will carve a larger area around it. And here you can see all the tool paths and rapid moves, just like in the other carving operations. And if I hit estimate machine time, it's about 153.3 minutes. So once again, I'll click Save Toolpath. I'm going to use that basic GCode-inch post processor, and then I will save this out to the folder on my hard drive where I'm keeping all these files. And I'm going to call this guitar body front contours. And then when I hit save, that's going to write the G-code file to my hard drive. And then, of course, like the other cutting operations, I'm going to save this project as a MeshCAM file so I can go back in and make any changes if necessary without having to put in the supports and all that stuff. So we'll just save that to the hard drive. Now, once I have these G-code files written, I like to check them in a program called Camotics. And this is a freeware program. It's a G-code simulator. So I can navigate out to my hard drive and then select my G-code files. And I'll start with the guitar body back contours. Click open. I'll leave the units as inches, and the tool table, I'm going to set that as empty. I'll click OK, and that's going to draw a simulation of that carving operation. And then I'm on the left menu, I'm going to select Toolpath, and I'm going to enter the parameters for the tool that I'm using, which is a 1/4 inch diameter spiral bit and has a length of 2.5 inches. I'll click Save, and that writes that tool into the tool table at the left. Then I will select Preferences, and here I can choose the machine that I'm carving on, and mine's a custom-made machine, so it's not listed here. But since it uses Gerbil, I'm going to leave it as an X-carve, and then I'll set the resolution to very high. And then at the top, I'll click the refresh button, and that will refresh the window in high resolution so I can see what that carve is going to actually look like. And I can turn off the tool paths so that I can really take a closer look and make sure that this is, in fact, how I want that carve to appear. And if I need to, I can go back in and change my tool paths if necessary. And then I can also check the control cavity to see how that's going to look, and that's pretty much exactly how I would like it to appear. And then finally, I'll check the front of the guitar body and make sure the carve is the way I want it to appear, and that the perimeter is what I expect, as well as the supports. So all that's left to do is to send the G-code from my computer to my CNC machine. And I'll use a program, it's a freeware program called Universal G-code Sender. And that allows me to carve the guitar body with the files that I just created. Okay, well there you have it. That is my basic entry-level approach for writing the G-code files that I will need to carve this on my CNC machine. Now, as I said in the beginning of this video, there are ways that you can kind of expand upon the techniques that I just showed you by sort of tweaking and manipulating the MeshCAM settings in order to get files which will carve faster and more efficiently. Now, the approach I showed you will work just fine, but as you start to get used to how MeshCAM works and kind of play around with it, you will start to develop your own ideas for ways that you can make it more efficient. For example, on the front of the guitar, I had one continuous cutting operation which handles the rough carve, the finish carve, and that can actually be broken out into separate carving operations, and then each one can be set up to be more efficient or as efficient as possible. And what you would end up with would be a G-code file for the rough carve, and then a separate G-code file for a finish carve, and then perhaps a third G-code file for a pencil cut around the perimeter. And then what you could do is in a text editing program, you could open all three of those G-code files and then copy out what you need from each one and build one G-code file. And then that way you will end up with the most efficient method for cutting and carving a body that will that you can accomplish much faster than the way that I showed. Now we're talking about not really huge savings in time, but it is enough to consider it, as well as an advantage of having a smoother, higher quality finish, surface finish, which will take less post-production work, sanding and that sort of thing. So I hope this video will at least give you an idea of what's going to be required to write the G-code. And for those of you who are skeptics of CNC, I hope that if you watch this whole video, you'll start to understand that in truth, when you're using CNC technology, this side of it, this is the front end of it, it's like you're exchanging your skills using a hand plane and a spoke shave for using software to write toolpaths and G-code. So it's really, when people say that using CNC is cheating, I have a feeling those folks have no clue what goes on the front end. So hopefully this video will kind of give you an idea of what's involved. At any rate, that's all I've got for this week. I hope you have a great weekend and a great week ahead, and we'll see you soon.